Welcome to Maths with EJD. This is the second video on coordinate geometry, and here we consider basic formulas in coordinate geometry. Basic formulas in coordinate geometry. So here we look at some basic formulas and straight to the point. I mean, it means that, of course, we already saw in the previous video that as inspired by René Descartes, a French mathematician, we can actually represent geometric. So we have the connection between algebra and geometry, right? Because you can represent points on a Cartesian coordinate system using the x and y or that pair from the x-axis and the y-axis respectively, where the x part is called the abscissa and the y part is called the ordinate. Okay, so so there are some formulas connected with coordinate geometry that are basic. For instance, we have the distance formula. That's the first thing we'll be looking at, the distance formula. Okay, so how do we derive the distance formula? So let 2 points in the Cartesian plane be A, x1, y1, B, x2, y2. The horizontal distance is change in x, that's x2 minus x1. The vertical distance is change in y, y2 minus y1. So using the Pythagorean theorem, the distance is AB equals square root of change in x all squared plus change in y all squared equals square root of x2 minus x1 all squared plus y2 minus y1 squared. I mean, basically, this is what we are saying as far as that is concerned. So imagine that you have this. Maybe this is point A, x1, y1. And then say we have point B somewhere here, x2, y2. So we are interested in this distance. Now the question is, how do we get that done? Okay, how do we find this distance? Using the fact that they have points like that. So you see here, we can have this line. Okay, so here you have y1 and this is y2. So the change in y here is basically what we can call, so you can have it as, since it's a distance function, right? We can have y1, y2 minus y1 or y1 minus y2, anyhow you like it. So let's say y1 minus y2 in this case, all right? And this other side now, by the way, you see this is right angle. And coming here now, you have x2, this is x1, this is x2, okay? So you can then also have this to be x2 minus x1. By the way, if you do it in absolute terms, you have y2 minus y1 will be the same thing as y1 minus y2. So using this now, we can then have, so using Pythagoras theorem, this is the distance we need now. This is distance AB that we need because this is A and this is B. So we are saying now that distance AB using Pythagoras theorem is simply square root of, or better still, we have AB squared equals y1 minus y2 squared. And since we are squaring it, it doesn't matter which one comes first. So we can say this is y2 minus y1 squared plus x2 minus x1 squared. So that finally, the distance AB is simply square root of x2 minus x1 squared plus y2 minus y1 squared. Like that. Okay? So that's how we derive the distance formula. So so with that done, we can see some applications of the distance formula. We see some applications of distance formula in in checking if a point lies on a circle of radius r. So you want to check if a point lies on a circle of radius r centered at h, k. So the center of the circle is h, k, and you want to find if a point lies on it. So the distance from x, y to hk would satisfy x minus y squared, all right? To satisfy x minus h squared rather, plus y minus k all squared equals the square of the radius, okay? So verifying if a triangle is isosceles or equilateral by comparing side lengths. So if you want to compare, if you want to see, look at all the sides or all the lengths of a triangle, you can calculate the distances. So if they are all equal, of course, that will be equilateral. If two of them are equal and the third one is not, that is isosceles. If they are all different, that will be scaling, right? So you can use the distance formula to take care of all of this. Okay, so then we talk about a worked example. So we want to find the distance between A 2,3 and B 7,1. Okay, 2, 3, 7, 11, right? 2, 3, 7, 11. A 2, 3, then B 7, 11. So we want to find the distance A, the distance between A 2, 3 and B 7, 11. Don't forget this is x1, y1. This is x2, y2. Okay? So the distance AB, like we know already, is square root of x2 minus x1 squared plus y2 minus y1 squared. So AB now is equal to square root of x2 minus x1. So x2 is 7, x1 is 2 squared. Y2 is 11, y1 is 3. Then you square that. So you have AB is equal to square root of 7 minus 2, that's 5 squared. 11 minus 3 is 8 squared. Okay? So you have AB equals square root of 25 plus 64. Okay? So that means AB is the square root of 89. Okay? That's root 89. Of course, we can break that down further by punching our calculator. So if we come here, we see the decimal thing. So if you take the square root of 89, you get 9.4, approximately 9.43 units. Okay. Of course, if you are given cm, that will be cm. If you are given kilometer, that will be kilometer instead of units. So whatever units, so 9.43 units. Actually, we can use Python to do this. So you need the distance to define function distance using point A and point B. So you Euclidean distance between A, x, comma, y1 and B, x2, comma, y2, A, x1, comma, y1. And then you return the hypotenuse, mat.hypot, B naught minus A naught, B1 minus A1. So you use that, and then you can plot the distance. So plot segment AB. So write triangles and show distance. Of course, we could have done that here too, right? Okay, I didn't even bother plotting the points. Okay, we can plot the points as you know, right? So, yeah, we can plot the points. You already know that. So, let me just move on. But I mean, it's always nice to plot the points so you can intuitively get the distance using Pythagoras theorem. So, then you do all of this math right there. And then, so you just substitute A, B, 2, 3, 7, 11, and you get 7, 11. And then you find the distance between A and B. And of course, you get your result spewed out like that. So you see, AB is 2, 3, B, A is 2, 3, B is 7, 11. And then, so using Pythagoras theorem, we get approximately 9.43 like before. So that is the distance formula. Another formula is the midpoint formula. Midpoint formula. So it's more like we want to get the midpoint of a line, right? Midpoint formula. So for a line segment with endpoints A, x1, y1, B, x2, y2, the midpoint M is x1 plus x2 over 2, y1 plus y2 over 2. So the geometric meaning of this is that the average of the x coordinates and y coordinates of the endpoints, it represents the center of the line segment joining the 2 points. So talking about midpoints now, if we take it back here, and we then have, say we have this now. So you have, say, point A is here. So you have x1. Point A is, let me take it down, x1, y1. And point B is here, x2, x2, y2, right? So this is A, this is B. So this is the line joining both of them. So if you want to get the midpoint of this, okay? So yeah, so we're saying that basically midpoint would be, so x1 plus x2 divide by 2, okay? Then y1 plus y2 divide by 2. So that's the midpoint. So somewhere around here. So I think we'll have a practical example to work with. So imagine that you want to find the midpoint of minus 2, 4 and 6, minus 8. Minus 2, 4. Minus 2, 4, 6, minus 8. Okay? Minus 2, 4, 6, minus 8. So A, minus 2, 4. B, 6, minus 8. So we can do the plotting. So this is 2, 4, 6, 8. So 8 is negative. Y is, we have 8 to the negative. So that's 2, 4, 6. And down here we have minus 2, minus 4, minus 6. So minus 6 and then minus 8 like this. So, and then here, minus 2, 4. So let's say we have minus 2, we have minus 4. So for point A now, minus 2, 4. So this is minus 2, 4. So that's the point A here. This is our point A, minus 2, 4. And our point B is 6, minus 8. So that's a 6, minus 8 here. So B, 6, minus 8. So we can join the line, the points together. So that's the line. I want to get the midpoint of this, right? That is the deal. So we want to get the midpoint. So we are saying that mid A, if you like, is equal to, so this is our x1, x2 now. So this is x1, y1, then x2, y2. So midpoint is x1 plus x2 all over 2, y1, so y1 plus y2 all over 2. So midpoint AB, right? So mid AB is equal to x1 is minus 2, x2 is 6 all over 2, then y1 is 4, y2 is minus 8. You add minus, so that's minus all over 2. So that mid AB is equal to minus 2 plus 6 is 4 over 2. 4 minus 8 is minus 4 over 2. That is 2, minus 2. And that is what we get. So if you come back here now, so it means that the midpoint is 2, minus 2. So that means if you lay this down, so 2, minus 2. So this is the midpoint. So this is the mid AB. That's the midpoint of that line right there. Okay? Is the midpoint. So the midpoint AB is 2, minus 2. So 2, minus 2. That's the midpoint right there. Okay? So back here now, so we see that's what we get, 2, minus 2. So the midpoint is 2, minus 2. So we can also use this Python code to take care of that. Okay? So you define the midpoint using the Python function. So you need point A, you need point B. All right, midpoint of AB. So that's A0 plus B0 over 2, A1 plus B1 over 2. And you do all of this. And then if you run this, so you can see the midpoint is at 2.0, minus 2.0, just like what we did right here. Okay, so we have that. Then the last formula, is it the last? Yeah, I think so. As far as this is concerned, there are many formulas in coordinate geometry, but these are some basic formulas. So the last formula we're considering here is what we call the section formula. So the section formula gives the coordinates of a point dividing a line segment in a given ratio. Okay, let me see. Was there a definition for this? Yeah, it's just straight to the x1, y1. So the section formula gives the coordinates of a point dividing a line segment into a given ratio. So we can have internal division. If a point divides A, x1, 1 and B, x2, 2 in the ratio m, n for internal division, then you can say that P will be mx2 Okay, so that's the point where the division takes place. So that's mx2 plus nx1 all over m plus n, comma, my2 plus ny1, all over m plus n. That's for internal division. But for external division, all the pluses turn to minus. So if you use plus internal division, if you use minus internal division, so mx2 minus nx1 all over m minus n, comma, my2 minus ny1 all over m minus n. As far as m is not equal to n, because if m is equal to n, that will be 0 and it will be undefined. Okay, so we have internal and external division like that. Okay, so the geometric meaning is that internal division is such that P lies between A and B, but external division, P lies outside the segment extending beyond A or B. Okay, so let's do some examples. So first of all, for internal division, we want to find the point P that divides the line joining 2 minus 2, 8, 6 in the ratio 1, 2. 2 minus 2, 8, 6 in the ratio 1, 2. So let's go to our worksheet. Okay, so uh we need to find the point that divides A, which is 2, comma minus 2, and B, 8, comma 6 in the ratio. So M, comma N now, M ratio N now is 1 ratio 2. Okay, this is x1, y1, x2, y2. That always helps in whatever you want to do. And we know the formula, so since you're dealing with internal division, so we can just say for internal division, okay, you quote the formula. The point P there is mx2 plus nx1 all over m plus n. Then my2 plus ny1 all over m plus n. So in this case now, P here would be m. So m here is 1, right? So you have 1 multiplied by x2. Our x2 in this case is 8, okay? So that's 1 times 8 plus n, which is 2 now, because m ratio n is 1 ratio 2. So n is 2, and x1 is 2. x1 is 2 all over 1 plus 2. Then comma, then you have my2. So that's 1 into y2 now is y2 is 6. Okay, so you have y2 is 6. N is 2 into y1, which is minus 2. Okay, that's minus 2 all over 1 plus 2 again. So that P now is equal to 1 times 8, 8, plus 2 times 2, 4, all over 1 plus 2, 3, comma, 1 times 6, 6, minus 2, 2 times 2, that's 4, all over 3. So now we have P to be 8 plus 4, that's 12 over 3. Then 6 minus 4, that's 2 over 3. So we have 12 over 3, 2 over 3 like that. Of course, now 12 over 3 is 4. So 4 comma 2 over 3. That is the point that divides the line into ratio 1 to 2. 4, 2 comma 3. Well, I mean, to save time, I'll just go to Desmos to indicate all the necessary points here. So we want to divide 2 minus 2, 2 minus 2, and 8 comma 6 in the ratio 1 to 2. So I go to Desmos. So first of all, we have 2 minus 2. Okay, so the label for that is A. So you can see 2 minus 2 right here. So that's A, 2 comma minus 2. That goes. And then we have the other one, 8 comma 6. So we have 8 comma 6. Then the label is B. So we have B. So you can see that up here. So you can see 8 comma 6 up here. So we have B. That's 8 comma 6. Okay. So the point that divides it into ratio 1 to 2 now is 4 comma 2 over 3. So we have 4, comma 2 over 3, like this. So that is one that divides it into ratio 1 to 2. So we can label that point now as P. Okay, that is our point P, which divides the line into, so this is AP is ratio 1, then PB is 2. So 1 to 2, like that. So that goes. And then for we have for external division. So for external division like this. So we want to find the point that divides 1 minus 3, 5, 1 minus 3, 5, comma 7 externally in the ratio 2, comma 1. So again, we take it back. So, okay. So here we want to find, we have A, which is 1, comma minus 3, and we have B, which is 5, comma 7, and we need something that divides it into 2, comma 1 externally. So we say for external division, like we already saw, for external division, all right. So we have, don't forget the P now is M x2, everything like before except for every plus becomes minus, mx2 minus nx1 all over m minus n, then my2 minus ny1 all over m minus n. Okay, so again, don't forget this is x1, y1, x2, y2, like this. So that means that our P, so the P now is going to be M. So don't forget the ratio. So this is ratio M, comma N now. Okay. So M is 2, N is 1. So we have 2. X2 is 5. Okay. That's 2 into 5 minus N, which is 1, into X1. X1 is 1 in this case. Then 2 minus 1 because M is 2 and that N is 1, comma 2 again into y2. Y2 is 7. So we have y2, which is 7 minus 1 into y1, which is 1. Sorry, y1 is minus 3. Y1 is minus 3 all over 2 minus 1 again. So we tidy that up. So we have P is 2, comma 5, that's 10 minus 10, we have 10 minus 1 all over 1, comma 2 times 7, that's 14, minus and minus, that's plus 1 times 3, 3, all over 1 again. So lastly, we have P to be 10 minus 1, that's 9 over 1, that's 9. 14 plus 3 is 17, that's 17 over 1. So it means that 9, comma 17 is what divides the points 1 minus 3, 5, comma 7, in the ratio 2, comma 1. Okay. Instead of plotting the points manually, let's go to Desmos and see what that looks like. Okay. So I take away all this now. So first of all, we have point A, which is 1, comma minus 3, like this. So you can see that right here, 1, comma minus 3. So we label it. So that's A, 1, comma minus 3, like that. Then we have B. B is 5, comma 7. Okay, 5, comma 7. Yeah, this is it right here. And the label, so you see 5, comma 7. So that is B, 5, 5, comma 7. And then we need a point P which divides this line AB into ratio 2, comma 1, ratio 2 to 1 externally. And we found that to be 9, comma 7. So we have now, 9, comma 17. So 9, comma 17. So we need to shrink this to see. So you can see 9, comma 17. You can see it's still on the line, but external to it. So we have the 9, comma 17. And then P. So we have P now to be 9, comma 17. So you see, everything is still the same line, but now 9, comma 17. Okay. So if we go back to this, we can do this using Python code. So you can look at the code like this. So it's basically following the formula and everything. So we do internal and external. So I'll just go ahead and run it. You can look at the code at your own convenience. So, but of course, all this you can do manually. Okay. So you can see that. So for the other one we did, so for 2 minus 286, we got 4 against 2 over 3. But for the other one, you see 9,17 is external to it, like that. Maybe I shouldn't have removed what I did the other time so we can see how they compare. Okay. So this is what we have, like we've done. So in summary, so look at the form. In summary now, we see that for the distance formula, the distance between AB is given as square root of x2 minus x1 squared plus y2 minus y1 squared. Midpoint M is x1 plus x2 over 2, comma y1 plus y2 over 2. Then the section, so if you want to divide a line into sections, for internal section, you have P is equal to mx2 plus nx1 over n plus n, comma my2 plus ny1 over n plus n. Then section, if you want to divide externally, you have mx2 minus nx1 all over n minus n, comma my2 minus ny1 all over m minus n. So that's the summary. And as usual, I have some 10 practice questions you can try your hands on, like that. So this one says, use the distance, midpoint, and section formulas to answer the following. Show working and leave exact sorts when appropriate. So in this case, it means you don't have to punch your calculator to find the sort. So you just leave your answer in sort form, basically. So find the distance between 3 minus 2, 1 minus 4. We've done that amply. Collinearity via distances. Determine whether 0, 0, 3, 4, and 6, 8 are collinear using pairwise distances. So it means to find the distance between PQ, QR, and RS, and then determine whether they are co-linear, like that. Of course, you can use decimals for some visualization. So you can try your hands on this and see how all these things go. Okay. Thank you so much for listening. It's been such a nice one listening to this, talking about basic formulas in coordinate geometry. Let me know how helpful this is. And if there's something like the trial, feel free to let me know. If you have subscribed already, I must say thank you very much. But if you have not subscribed, of course, you don't want to keep missing this excellent content I have going on here. So go ahead and subscribe. Why not? And then, of course, having done that, hit the notification bell so you can always get alerted each time a new video is released. And once that is done, feel free to, take a step further. Click on join to become a member of the channel. You see 3 levels of membership with some special perks, with some extra special privileges, and let's build this community together. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.